Welcome and study with Tanzania Institute of Education.
Hello student, welcome to your lovely lesson of Basic Mathematics Form 4. Here is your teacher, Mr. Sinde Juma. We are going together to discuss a topic which is known as areas and perimeter, as it is seen on the board here. Today, in this topic of areas and perimeter, we are going to discuss one part which is known as area of any triangle. I know that in Form 2, you have discussed the part which is known as area of a triangle, but specifically right-angled triangle. But now we need to generalize. How can you find the area of any triangle, whether it is Scalene triangle, whether it is right-angled triangle, or isosceles triangle, or you can have even equilateral triangle? How can you find the area of that particular triangle? This is the lesson that we are going to discuss together. With you, take your equipment so as we can do it together. Welcome. In our topic, we have objectives, and in this objective, we need to discuss how to derive the formula of any triangle. That is the first part that you're supposing to know how to derive. And the second part is we need to know how to solve the problems concerning to any triangle given from the four mentioned triangles that we know. So in order to know this one, how to derive the formula, first of all, we need to know how the things, the common things that you remember, the terminologies that can help us to derive this particular formula. And these are the first terms that can help us to know. The first thing, it is known as included angle. The first term, it is known as included angle. We need to know first, what is included angle? Actually, in any triangle or in any two lines which are going to intersect somewhere, the point where those two lines they intersect, they form an angle. And that angle, which is formed by two lines which intersect somewhere, that angle it is known as included angle. So, for example, you have the first line in this one, and the second line in this one. You have a first part of a line, line A, and the second part of a line, it is line B. The angle which is in between here, between the two lines, this one, it is known as included angle. Included angle. That is the first thing that we need to remember before we derive our formula. The second concept we need to remember, the concept concerning to right-angled triangle. I know you are very familiar with the right-angled triangle, and in this one, we are going to focus on only one part, which is trigonometric ratios concerning to right-angled triangle. So the second part, it is a right-angled triangle. In any right-angled triangle, I think you remember that we have three sides, but the main side that you need to focus on, it is the side which is faced by this angle which is 90 degrees. So if we're talking about right-angled triangle like this one, let's say, for example, this one is our right-angled triangle. That is where we have our 90 degrees. Then this side that you are facing, it is known as hypotenuse. And the other two legs, they are known by their names as concerning to the angle that we're talking about. For example, our angle in this right-angled triangle is this one. Then the side which is faced by this angle, which is not 90 degrees, the side which is faced by this one, it is known as opposite side. This is opposite side. And the remaining, the third side, it is known as adjacent side. So by knowing this one, we can have those trigonometric ratios. And the trigonometric ratio that we need to focus on, it is the one which includes this angle, the opposite side, and hypotenuse, which is known as sine. Sine of our angle theta equals to the opposite side divided by hypotenuse. Now, these are the major two concepts that you need to, they can help us to make sure how can we get to know how to derive the formula of any triangle. Now, let us derive the formula of any right-angled triangle. Consider derivation. derivation of our formula. Consider any scalene triangle. Let's say we have our scalene triangle as the following. Consider scalene triangle. As we know that a scalene triangle is a triangle in which all of its three sides, they are not equal. So for example, we have our scalene triangle like this one. The first side is this one, the second side, and let's say here we have the third side. Once we observe these three sides, we find that all of them, they're not equal. This side, this angle, let's say we call it A. The second one, it is B, and this one is C. Once we need to find the area of this one, actually, it seems like it is very difficult to find the area for this one. Why? The concept that you have for any right angle triangle that we have, in order to find the area, we need to take a half times base times height. But this one, we have a base. Actually, we can say AC, it is a base. But what is our height? Can you guess? Actually, for this diagram, it is a little bit difficult. So what can we do? We have to construct another line in this this scalene triangle, in which is going to be forming 90 degrees with this base. So how can we do it? We construct a line from this point to be here. Here we get 90 degrees. In this point, let's say we call this point E. It is point E. Now once you observe this one, we have scalene triangle, the large triangle ABC, but within it we have other two triangles, in which we have the small triangle BEC, and the other one, it is triangle ABE. If we find the summation of these two triangles, we are going to get the area of the whole triangle ABC. So now how can we get the area of this whole triangle ABC? Let us observe it. This BE, it is our height. Let me write in this part here. Given that BE, this one, it is our height, and EAC, this one, it is our base. So from the concept that we have, we know that area of the whole triangle, triangle ABC, can be obtained by taking a half times base times height. But how can we get for that one? By using these symbols. We can find that it is a half times base. Our base is side AC, and the height, it is BE. We can say that this is our area of triangle ABC. But still we have a question. We have to ask ourselves, areas found by taking a half times AC times BE. But if you remember, this side BE, it is the one that we constructed ourselves. It was not there in the original diagram. So we have a question. From the original diagram, this side was not there. But in the formula, it is there. How can we eliminate this one so as we can get a general formula which will consist of only this side, side AB, BC, and the AC, excluding this BE. So in order to know that formula, we can call this one, it is equation 1. So we have to find another formula which can help us to eliminate BE. Here we are going to use the second concept of right-angled triangle that we have discussed right there. How are we going to use it? From the right-angled triangle, which triangle? Take the small triangle BEC. Triangle BEC, which seems to be like this way. Here you have your angle, which is angle C. This one is E, and the top here it is B. For this one, right-angled triangle, whereby here we have 90, in order to find the relationship which exists between the angle C, the opposite side which is faced by this angle, and our hypotenuse BC, we are going to use the concept of trigonometric ratio, which is known as sine. So how can we get to know the sine of this angle here, which is angle C? Sine of angle C will be obtained by taking the opposite side, in which it is our BE side, divided by the hypotenuse. Hypotenuse is what? Hypotenuse is BC. It is BC. Now for this case, we get our value of BE. Once we make it the subject, it will be BE equals to BC multiplied by sine of angle C. Multiplied by sine of angle C. This is the second equation. So up to now we have two equations. The first equation is concerning to the general formula of our triangle, but we said we have this side BE in which we constructed ourselves, so we have to eliminate it. How do we eliminate? We are using the second formula, which says BE is the same way as to say BC multiplied by sine of angle C. So let us take this one, substitute in the first equation. What are we going to get? By substituting equation 2 into 1, the first equation, if we take the second equation, this one, we substitute it in the first equation, what are we going to get? We get the total area of triangle ABC will be equals to a half times our AC value multiplied by BE, in which BE, it is from this side here, which says BC multiplied by sine C. So if we take, instead of writing BE, we are going to write the whole thing here, BC sine C. What are we going to get? Write it there. It will be BC sine C. So now our triangle ABC, its area is obtained by taking a half times AC times BC sine what? C. This is our general formula, but we have to generalize so as we can understand it very clearly. How can we explain it? Generally, we say this. Generally, if you have your scalene triangle, your scalene triangle like this one, then you have your angle in between here, your angle theta. You have your side, this is side A and this is side B. We need to generalize the formula concerning to what we have got here. Observe this one in our diagram that we have drawn here. The area of triangle ABC, it is obtained by taking a half times AC, observe it very careful, AC multiplied by BC multiplied by sine C. Where is sine C? Sine C, this is what I want you to focus on. Sine C, this angle C, it is the angle which is between line AC and line BC. So, in order to get the area of any triangle, you must have two sides and the included angle, the angle between the two sides. So as you can take a half multiplied by the first side, multiplied by the second side, and the sine of the angle between those two sides where they intersect. The answer that you get, that will be the answer for the value of the area of the whole triangle. So for the case of generalization in our scalene triangle, this one, we have side A, we have side B, and the included angle is angle theta. Therefore, if we need to know the area for this triangle, we need to take a half multiplied by the first side. The first side is side A, multiplied by the second side, which is side B. Then we multiply by sine of the angle between the two sides. Which is angle? Very nice. It is angle theta. So here we just write angle theta. This is our general formula to find area of any triangle, whether it is isosceles, whether it is equilateral, scalene, and whatever. If you need to find the area, you are using this formula in order to get the area. If we have a right-angled triangle, why do they say right-angled triangle? Why do they say the area of right-angled triangle must be a half times base times height? There is no sine and whatever. For right-angled triangle, we have a special case, this one. This is our right-angled triangle. Our angle here is 90 degrees. This is side A and this is side B. So if we need to find the area for this particular triangle, how can we write this one? By following the area that we have derived here. The area for right-angled triangle will be equals to a half times A times B times sine of the included angle, the angle between here, which is what? 90 degrees. But we know that sine of 90 degrees equals to 1 always. For this case, if sine of 90 equals to 1, what are you going to get? We are going to get area equals to a half times A times B, whereby your A, it is a base, and B, it is your height. That's why always they just say in area of a right-angled triangle, it is a half BH. They used it right this way. So don't ask yourself so many questions. Why do they use that one instead of this one? This is a general formula, but this one, it is a specific for only right-angled triangle. It's my hope that we are together up to there for this how to derive a general formula concerning to any triangle. Now, let us see few examples concerning to solving problems concerning to any triangle that we have. How can we solve questions concerning to area of any triangle? Let us take example 1. Example 1. Find the area of the following diagrams. Of the following diagrams. Diagram A, we have triangle like this one. Here it is 30 degrees. Here it is 11 centimeter, and this one is 12 centimeter. Diagram B, let's say you have your triangle, this one. Here you have 45. This one is 16 centimeter, and here you have maybe 10 centimeter. We need to find the area for those two triangles. Now, what will be the solution for these triangles? How can we get the area for the two triangles? Solution. Solution. For diagram A, we know that area, it is obtained by taking a half times A times B and the angle which is between the two sides A and D, and B, sine of the angle which is between the two sides A and B. So for this case, if we observe our diagram there, we find that A value, it is 11 centimeter, B value, it is 12 centimeter, and the angle between them, it is 30 degrees. It is 30 degrees. So it's just a matter of substituting in our formula. Our area will be equals to a half times A, which is 11 centimeter, times 12, which is value of B, and the sine of 30 degrees. But we have to know what is the value of sine 30. On your mathematical table, you may just open and read what is the value of sine 30. Sine 30, it is how much? Yes, it is 0.5. So here you can say, but sine 30 degrees equals to 0.5. What will be our area then? Our area will be equals to a half times 11 centimeter times 12 centimeter times 0.5. Here, this one and this one will be 6. So we get 11 times 6 times 0.5 centimeter, and centimeter will be centimeter squared. The answer will be equals to here 3, and this one is 33 centimeter squared. So this is the area of our triangle in part A. That is the area of a triangle in part A. For part B, we can do the same. We are given two sides, 16 centimeter, 10 centimeter, and the angle between it is 45. Thank you very much. Now, what will be the area? As we know that area, it is a half times the first side, the second times sine of the angle in between. And our angle, I mean the first side, side A, it is given as 16 centimeter. The second side B, it is given as 10 centimeter. And the angle between them, it is 45. Yes, it is 45. Thank you very much. Now, if we substitute it here, what are you going to get? We get area equals to a half times A, which is 16 centimeter, times 10 centimeter. Here we are going to get our area equals to times sine of our angle between, which is 45. Thank you very much. Thank you very much for reminding me. So once you substitute, what is the value of, once you read in your mathematical table, what is the value of sine 45? Sine of 45? Okay, it is a special angle whose value is radical of 2 over 2. So this one, it can be 8 centimeter times 10 centimeter times radical of 2 over 2. Here, this one and this one will cancel, will be 5 times 8, it is 40. So we are going to get 40 square root of 2 centimeter squared. We can leave our answer in sad form like this one, but it must be in a very simplified form. So these are some of the examples on how can we use our general formula to find the area of any triangle that we are given. Now, I can give you one more question which is of different form, which can help you to use this formula. The other one, example 2, the other example, find the value of B in the following diagram. Given that the area of a triangle is 150 centimeter squared. 150 centimeter squared. Our diagram is like this one. The angle between here, it is 30 degrees. You have the first side, which is 40 centimeter, but the second side, it is B. So we need to find the value of B, given that angle between 30 and the other side is 40 centimeter. Now, we can do the same by using our formula. The formula says area equals to a half times AB sine of angle between. Now, once you substitute, we are told that area equals to 150. So we'll substitute here 150. A half times the first side A, it is 40. The second side B, it is the one that we need to find, times the sine of our angle between is 30. So here we write 30. Now it is possible to get the value of B, since we know that sine 30 equals to 0.5. Now for this case, here we get 150 equals to 20 B times 0.5. 20 times 0.5, it is 10. We get 150 equals to 10B. If we divide by 10 throughout, by 10, this 10 and this one will cancel. We are going to get the value of B equals to 15 centimeter. So it's not always that you are going to be given a question in which you are supposing to use area, but sometimes, as you know, the format of the formula, you can be asked to find anything. What you're required to know is you can use the concept of area to find anything which is required by the examiner. Thank you very much for this wonderful lesson. Thanks for being together up to here.
Let's study, be educated.